You probably think you know how if statements work. CS 101, right? We check the condition, we take either the true path or the false path. Life wasn't always so simple. Behold, the Fortran arithmetic if statement. This if can jump to three different places depending on whether the expression is negative, zero, or positive. It's basically three goto statements in one line of code. That's what code looked like in 1968 when the great computer scientist Edgar Dijkstra wrote his famous letter against the goto statement and mailed it off to the editor of the communications of the ACM. Ever since, programmers have trembled at the thought of using a goto statement in their code. Was Dijkstra right? Here's some more Fortran code written in the early 1970s for an IBM mainframe. It was probably entered using punch cards. I'm glad I'm not a Fortran programmer. This code is crawling with goto statements. There weren't labels back then, so the targets are all line numbers. Look at that first one in the if statement. Our coding forefathers, Fortran fathers, didn't have curly braces to define blocks. Instead, they used gotos, including unconditional jumps sometimes at the ends of blocks. Here's another snippet that shows the do loop syntax, which is sort of like a for loop. There are actually three nested loops here, but it's hard to tell because none of this code is indented. There are no curly braces and no structure. It's more like assembly, which tracks because this was the early days of computing and lots of coders were used to programming in assembly. We also have a bunch of those arithmetic if statements, each featuring three gotos. Pretty much all this code seems to do is jump around to line numbers. You can see how this must have led to a lot of bugs. Dijkstra and others, they were right to throw the red flag. The rest is of course history. Everybody switched to structured programming. Now we have languages like Python and Java that don't even have a goto. But I think we've gone too far. Goto can make your code easier to read if you use good labels. Here's an example. Even though I didn't give you any context, you can easily imagine what the surrounding code probably looks like. You'll often see this goto pattern used to exit nested loops. Another example. Again, it's not hard to picture what the rest of the code looks like. It's a retry loop, implemented with goto to reduce indentation. Error handling is of course the classic goto pattern. The housekeeping stuff is separated from the business logic, making it easier to understand the purpose of the function. What I like about goto statements is that they tell you where and why control is transferring if you use good label names. Think about it, we give names to all our functions and variables, so why not also name our control flow structures? Conventional structured programming constructs are not as descriptive. You have to read more surrounding code to understand the where and the why. Now, my point isn't that goto is always better than break and continue, far from it, but I think goto is often the more readable choice. Is this a slippery slope back to 1970s Fortran? Did you already forget how bad Fortran was? I'm not going to subject everybody to more Fortran code, so here's a cute cat video instead. And no, your code isn't going to turn into Fortran just because you used a goto. I think it's pretty easy to avoid spaghetti if you stick to these simple goto patterns. The rule with goto is you always want to be jumping within or out of the current scope. You don't want to jump into the middle of a scope from outside because variables will not be properly initialized, and it's confusing, or even illegal in C++ when objects are involved. Admittedly, this is a challenge for those of you who like to declare and initialize variables in the middle of scopes. You're really creating a new implicit scope for every variable when you do that. Goto mixes better with the traditional C style of always declaring variables at the beginning of a scope. So, what about all the well-meaning experts who oppose goto? Many experts have actually expressed a nuanced view, including even Dijkstra. Here he is quoted by goto lover Donald Knuth. Please don't fall into the trap of believing that I'm terribly dogmatical about the goto statement. Goto hater Bjarne Stroustrup has said, the fact that goto can do anything is exactly why we don't use it. But his style guide does allow goto to exit nested loops. Interestingly, that same style guide also advises against break and continue. Myself, I avoid C++, it's just too big for me. Linus Torvalds uses goto. They are often more readable than large amounts of indentation. There are thousands of gotos in the Linux kernel. Watch my Linux kernel goto video to see them all. Most of the Linux kernel gotos are for error handling and cleanup. But there are plenty of places in the kernel where goto is used for other types of control flow. And I want to show you an example. Alloc pages slow path. This is a core memory allocation function. It's called when there's not a free page readily available in the fast path code. This attempts to allocate a page using increasingly expensive and drastic measures like freeing I/O caches. In the extreme case, the out-of-memory killer is invoked. The function only goes as far as the caller requests. If it runs out of things to try, it jumps into a no-page state. After an expensive operation, the allocator often jumps back to its initial state to retry the allocation. For simplicity, I'm going to condense the progressive steps into a single block so I can show more of the actions, such as the no-fail mode. Another thing that the code checks for is a reconfiguration of system memory or task policy. Seriously, as in another memory chip is added during the allocation. Now that's obviously rare, but it's a corner case that the code has to handle. If the rare case happens, the whole function is restarted. Essentially, there's an outer loop around that retry loop, but it's not executed very frequently. So now we have this crazy flowchart, which is implemented with lots of goto. Probably many of you are completely horrified by now and thinking about ways this could be rewritten without gotos. I think it would be kind of awkward. You'd either have to write helper functions with lots of parameters, or you'd have to add new variables. The thing to understand is that the logic is a kind of state machine, and the gotos are used to transition between states. The code follows the principles I described earlier. The variables are set up at the top of the function, and there aren't a lot of assignments once we get into the logic. It's a very flat function. The labels are all at the outermost scope. I encourage you to review the code yourself with an open mind and try to appreciate the splendor of all the gotos. This has been a very C-oriented video. But what if your favorite programming language doesn't have goto? Is it time to pick a new language? Most of these languages, of course, have alternatives for some goto patterns. Language designers know in their hearts that goto is awesome, so they keep coming up with other names for it. For example, Java and Rust have labeled loops so you can break out of nested loops without goto. So that's kind of cool, although it's kind of weird to me that the label is found at the beginning of the loop, but that's not where I'm going. I'm going to the end of the loop. With goto, a simple Control F gets you to the right place. The label at the beginning of the loop makes more sense when it's being used with the labeled continue statement. Go, which does have goto, maybe it's because Ken Thompson insisted, has a defer keyword to invoke cleanup code when exiting a scope. There's been some talk of adding a defer mechanism to C, as many of you commented in my other video. And GCC and Clang already have an attribute to do it. I'm on the fence about defer. As a C programmer, I like my code to execute in the order I'm reading it, from top to bottom. Defer and destructors are like secret gotos at the end of a scope. It doesn't seem natural. Like, if you asked a normal person to write out the steps for baking cookies, it might look something like this. The recipe is at the top, and then you clean up when you're done. Here's the same recipe with the defer pattern. Everything happens out of order now, and my brain is turning inside out. Dare I say, it reads like a spaghetti recipe? Having said all that, maybe defer isn't so bad if it's used for simple cases like freeing a temporary buffer or closing a file. It's like a destructor. But I would advise against putting multiple statements in a defer block lest your code turn inside out. For that, maybe what you really want is a finally block, which is of course used by several programming languages for cleanup and try except blocks. Which brings us to the discussion of exceptions, which are of course used by several languages, for example Python. Exceptions are like super gotos that can leave your function, and it's often a bit of work to figure out where you're going to end up. Here, the Python fact proposes a way to use exceptions to implement what they call a structured goto. The funny thing about Python not having goto is that there are thousands of gotos in their CPython interpreter. There is some hope for Python. Maybe you could try this PyPI module out. There's also an analogous project for Rust. It looks like neither of these have been updated a while though, so who's going to step up? Anyway, that's all I've got about goto. It wasn't an exhaustive discussion of every control flow mechanism. But I encourage you to give goto a chance. Indeed, I challenge you to use goto in your code if you're not already. Let me know how it works for you.